So even though this was hardened in the way it should have been, because of this link, the attacker was able to completely bypass the network security controls in place.
Yep. The next slide actually talks about that. So this here is the query to enumerate link servers. Again, they get the information about the link servers through the cast method. The link servers are actually stored in a table called sysservers, and what we see them doing is enumerating information, where server ID equals 0 through n until they've enumerated all of the link servers, and then they get the name of the link server. And once they have the name of the link server, what they can then do is, not sure if you can see this, but essentially run commands against the link server. So what they're doing here is running a SQL statement which actually drops the table and then inserts into temp exec. So they're running a TFT command against the link server, not the database server itself. It's a fairly complicated query, but we've seen tools that automate all of this. So it's a no-brainer. In this instance, TFTP actually failed. So the corporate network was, had some egress filtering that did not allow for outbound TFTP connections. So what we then see them doing is, to prevent these kinds of network controls, they actually upload malicious tools into the database itself. And what they then do is dump out the malicious tool into a file and run the file. What the malicious tools often have are hard-coded IP addresses that allow the executable to connect out on a port that's that egress filtering doesn't control, like 443 or 80, to an IP address that they control. So here is an example of malware being input into the table. Essentially what they're doing is hex encoding the malware and splitting the malware into different fields and storing those fields into a table. There is a typo here. I've actually replicated the values, but the hex values are actually different across the 48 fields in this instance. We've seen up to 128 fields inserted into a temporary table that they've created, and what they then do is dump all of these uploaded fields using the bulk copy tool, and this query actually talks about that, and then use the query out feature to actually create the executable on your system. So as we can see, it's, the techniques that they have been using are fairly complicated, although the tools automate the complication. It automates the creation of the queries against the link servers. It automates enumeration of the link servers. And like Marshall said, it also automates querying information about the companies that that is of relevance to them.
This particular command right here actually is implemented in SQL Ninja, for example. There wasn't even we're not talking about tools that the attacker had to go out and custom write. In this case, they did, or in the cases that we've been looking at, they have written them. But lots of available SQL exploitation tools implement all of these things we're talking about.
All right. What we've also seen them do is, now the reason they upload the malware is for a number of reasons. One is gain persistence onto the network, but beyond that, also try to enumerate information and exfiltrate data from the network so the data is not logged on the IIS web servers. And for that, what they do is create a malware and then copy the malware as a backdoor ASP page onto the website, and then use this backdoor ASP to run their queries. Now, the queries, the backdoor ASP that they implement typically has them post data, and the body of your post request is not typically stored. So they bypass any detection mechanisms that rely on logs, using these backdoors. Also keep in mind that IIS logs only the first 4,097 characters. We've seen instances where they create queries that are longer than 4,097 characters, in which case the IIS server does not log the GET request at all. Any questions so far? All right, the next two case studies, we're going to keep pretty brief. This case study actually revolves around not an incident that we actively investigated, but as a result of a company calling us to perform a scan on advanced persistent threat. And yeah, let me provide you the layout of the company. And, yeah, it's a manufacturing client. Their security program essentially entailed performing black box penetration testing against their applications. And in this instance, the applications returned customized error pages. So more likely that the pen testers who looked at the application did not find SQL injection given the customized error pages. The client engaged us for our threat identification program, which actually is a different service. Do you want to talk about that briefly?
Sure. Does anyone here not know what the Advanced Persistent Threat is? Or APT? Okay, APT is just kind of a generic name that's been given to a threat or a group that has successfully penetrated a number of entities in the US. They can be governments, they can be companies, they can be almost anything you can think of. And they're very good and very adept at what they do. What we see them do is using whatever initial vector they need to use to get into a company, they get a foothold. Once they get a foothold, they simply dump legitimate credentials. We'll see them go to a number of different machines to dump as many credentials as they can find. Eventually, they'll get your domain admin or your enterprise admin passwords. Once they have that, they'll then use a couple of those accounts to simply log into machines via network-based logins throughout your network, kind of the way you guys would do, right? We've even seen them use RDP, VNC, Dameware, just like you guys do, just like regular administrators. So we're not finding malware everywhere. Instead, they're using legitimate credentials to log in to different computers throughout your company. They're then placing certain command and control channel backdoors on certain systems that they use to do everything they need to do. If they need to regain access because you discovered they're there and you change their passwords, they come back in through that backdoor that they've placed and only place them on a couple machines. So it's very hard to find, very hard to detect, very hard to get rid of. And when you do go in there and you clean up and you're pretty sure you've gotten rid of them, they move simply to a different type of technique and then you have to start all over again, which is why it's called the Advanced Persistent Threat. It's there, they're very good, and they're very difficult to get rid of.
Is that like a single entity you're talking about right here, or that's just lots of people?
That's one of those big question marks.
So, I mean, we have some insight into this, and we were hired to perform a scan of the network looking for this particular threat. What we did was look at the logs, the IS logs that the company maintained, and what we found in those logs were sort of weird-looking SQL injection-related tags. It doesn't look like a complete field, SQL injection, successful SQL injection tag. But on further investigation, what we found was that they had stored procedures that actually ran queries on these fields, or the values returned on these fields. And what these stored procedures did were restrict the length of the field to, I think it was 8 characters. So what we, from the IS logs, what we were able to find out was that what this particular attacker had done was split a successful SQL injection tag across multiple fields using the common characters. So in this case, given that the stored procedure had restricted field lengths to 8 characters, they were able to bypass the restriction by actually splitting the SQL injection tags across multiple fields. Now, the reason we believe that their security program may have failed was because the signatures that most automated solutions scanners, like the commercial ones, use typically have a length that's greater than 8 characters. And also, when it comes to manual pen testing, we typically use injection tags that we know to work. And given that they're implemented